intended
Hello
to
everybody.
get some
I believe you
programming
yourself
skills
intended
on
to
your own.
you
Thanks
are
for watching. Take care. Have
well
a good
today.
day.
All are fine.
Thanks for watching. Take care. Have a good day.
Viewers, couple of days ago, an idea clicked to my mind that why not to prepare some tutorials on LogixPro Simulator. Well, LogixPro Simulator is I'm not going into the detail what is PLC and how to program it, what is ladder logic, and what are the options available to program, or a compiler options are available. I believe you are familiar, but what all I intended for is to go through some kind of exercises so that the student can get a good grip on their ladder logic programming skills. They can enhance their ladder logic programming skills. So the best option or the simulator available option was this LogixPro. So what is the LogixPro, viewers? The LogixPro is hold on a second. Sorry, this is very annoying, honestly. Right click on it, and for me it is annoying. I don't know, excuse me for that. So what I was talking about, the LogixPro simulator is an interactive educational tool developed to assist students in the acquisition of the programming skill commonly used in the PLC control of process equipment and system. This is all about the LogixPro. I believe, I trust you know about this, you are familiar with it. So, and one more thing, we can see it is distributed by the learningpit.com. If you click on it, if you don't have installed already on your system, then open their web page by clicking on this, and it will take you to this window. So then click over here where you can find option how to download or how to buy. Proceed with that by downloading, by following these steps, and install it. Once you are done with the installation, go to the start menu and look for the directory the Learning Pit, as it's the product of Learning Pit. Then go into the LogixPro and click on this four color icon, circular icon, LogixPro. It's probably Logix is already running, and so this window will appear. So as the viewers, as I mentioned earlier, my aim is to go through all these exercises so that we can enhance the initial step. Click new, then start a new project, choose a appropriate MicroLogix controller. In my case it is MicroLogix 1000. Give it a name, this processor, for example, MicroLogix 000. Click OK. On there, on the left hand side, untitled, this is the project window. It is just resembling the real time environment when you are programming through RS Logix 5000 software, or compiler, or Rockwell softwares, or Simtag, whatever it is. So this is just to give you an idea how it will be look like in real time. So this is the programming area, programming window, with the title of LAD2. If you go to a program file, program option over here, you will see LAD2. Double click on it. You can give this LAD2 a name, whatever it is. For example, let's say a simulator, door simulator. Okay, so this is a door simulator assignment or exercise. Click on it and you will see this is changed already. It appeared over here. So let's start with the programming now, and the next step is choose the door simulator option. If it is not clicked already, click on it and then close this so that you can see it here. There's a door, there are two limit switches with the labels of LS2, LS1, LS2, and their designator input address is their input 104 and input 103, and there is a panel, control panel. On the control panel we have some inputs, open, close contacts and stop contact, and then there are some output indicators, shut, open and ajar. In addition to that, there are two motors, motor up and motor down, connected on the address output 201 and output 0200. And then there is one more option over here, this panel, this field, which is where we can find our ladder logic programming instructions, user, where you will find a rung. Whenever we need to create a new rung, click on it, and then there's a branch, examine if close button, examine if open button, and output energize, output latch. There are several. You can just click on it and find there are timers instructions, there are input output instruction, compare, math, and many more. If you do not, all are not visible, but you need to click left and right according to your requirement. Whatever instruction is required, you can click, choose, and just drag and place. That's all. So let's start with this door simulator programming or problem statement. Where to find it? Okay, so a good question. Go back to the learning pit website and click on left hand side tab and search for LogixPro or RS Logix documentation and student exercises. Then choose the appropriate one which we are going to program, which is a door simulation. Click on it, go through this all problem statement. It is divided into 4 parts. We'll go back to the bit instructions where I can find, I'll start from the output side. We have 2 motors, and these 2 motors are actually responsible to perform some actions, taking this door, opening this door and closing this door. These 2 motors are responsible for this action. So let's start with by placing output energize on the first rung, and then place this address. Just click on it, drag and place over here. You'll see the address, the same address will be appearing. Now we can give it a name. We can, by right clicking on it, then click edit symbol, give it a name, appropriate name, motor up, then click anywhere outside. It will label it with motor up. Then we need to place another rung. Go back to the user tab, place another rung, and what is next? Motor down. We need to place another output energize contact on the second rung. Again, do the same action, drag and place over here, right click, edit symbol, motor up, or give it like this. Okay, so then there are some input contacts. Those are responsible to open and close. Whenever open button is pressed, open button on the control panel is which one? Motor up should turn on, which will be taking this curtain or this door from floor from bottom to up. So then 2 control inputs. Let's place examine if close, hold, drag and place, and similarly we have to place another button, hold, drag and place, and these are 2 buttons which will be turning on the relevant or respective motor. And then this should be whenever in between we will click on the stop button, it should stop wherever it is. So let's place this in series like this, and hold, drag and place, hold, drag and place. Okay, Let's test on this show PLC control panel. You will be seeing PLC control panel options where you will be finding run button, step button, STP, and the programming mode. Whenever we are implementing our logic, we have to have in this mode, otherwise it will not allow us to do any editing. So when we are done with our implementation, then we need to click on the download, and now click open. See, it's opening, it's opening, it's closing. Okay, till now it's working fine. Now our aim is to, whenever we click on open button, it should open it completely, or if we click on the close button, it should close it completely. So we have to implement interlock or a latch phenomena. So let's take it back to the programming mode, switch to the instruction panel, put a one branch over here, take it into the branch and place one examine if close button, drag this output connection here, and do the same thing with this rung and place one examine if close contact, drag this and place over here. Now go back to the programming options, download, run, and click send. Let's see what will happen. Look. Okay. Look. See, this is another constraint of the present exercise. It has to be smart enough whenever I took it back to the mode, and now let me explain to you. Logic code or algorithm should be smart enough. Whenever we will turn it on, the motor up, the motor down should turn off, or vice versa. Okay, so in this case what we need to do is place one examine if open on both rungs, and drag and place this, drag and place this. So by doing this, it will ensure that one motor at a time will run. Okay, there will be no crash. Sorry, read the status of this door, whether it is open up to the end or it's completely closed or no. So we have two more input contacts labeled as LS1 and LS2. So let's start with them. Okay, and place. We forgot to label it. Let's label it. Okay, stop, and then place LS1 on the first rung, and LS4 on the second rung. Okay, so if you hover mouse on LS on either limit switch, you will see it says that normally open, not activated. It is for, and it is in fall condition when door is fully open. Okay, and on and LS2 limit switches in series to get AND operation. So LS1 added their symbols, LS2. So whenever these switches are activated, it will turn off the respective motor. So let's try this again, back and download and run. Let's try to open it. We'll see whether it will close this one, it will stop the motor or no. Yes, it is. Now close it completely. It is not activating. Oh, it is so. Oh yes. So we have to read our problem statement very carefully, as we can see, when both switches are off, then it means in this condition door is completely open. So then we can only close it. So we need to change our logic, take it back to the programming mode, go back to the instruction panel, and then change our examine if open. Alright, so take this one at the beginning. This is whenever you will press a stop button, it should stop it completely. So change, this is a good practice to keep it at the beginning. To turn on the corresponding indicators as well. When door is open, there should be an indicator which will state that, which will show that door is open. Okay, and when it is closed, it should turn on this one. And when this one is in process of opening or closing, then it should lit up HR output indicator. So let's start by implementing this logic. Okay, then we need to place another rung, hold, drag and place, sorry, click here and then place one here and one here, and give it a name, or place their addresses open. So let's place this address here and place ls1 and ls2 here. Similarly, place 2 when both ls1 and ls2 limit switches are closed, it means are on high position, high state, then it means the door is fully closed. Okay, do you agree with me? Yeah. Okay, then by the time it should lit this shut indicator up. Okay, so let's place energize output energize for shut up. I mean this one, add the symbol, set open lamp, then added the symbol as well, shut lamp. Okay, so alright. Okay, when it is in between opening and closing, it means it is in process, not completely closed, it's not completely open. So we have to implement that logic also. Here it is. Now place one examine close, one examine open button, this one and that one. All right, and place another branch, take these two inside, place same two contacts, place this one over here and this one over here. Then there should be output energize for HR. Okay, I trust that you are getting me, you are following me, what I'm implementing, what I'm trying to do. So okay, so this is all about for this door simulator assignment. Let's download and test it whether it is fulfilling our constraints, assignment constraint or no. Download. Okay, we did not and give it a name, let's say ALJAR. Okay, so everything is labeled, everything is there according to the assignment or problem statement. Program run. Okay, as we can see now, when the stop button is on high, it means when it is low, it means we have to stop it, we have to close everything. So it is high already, and we can see the door is fully, oh, why it is so, maybe we need to reset the simulation. Okay, take it back and reset the simulation. Download again, take it back. Okay, fully open. Yeah, we need to change it, shut indicator and open indicator. Okay, so we need to replace these two. Take it back to the edit mode, and this one should be here, and this one should be 3, right? This one should be open. Okay, so this open lamp. Okay, program run mode. Yes, okay, now it seems okay. So door is fully closed, and the relevant indicator, which is a shut lamp, is also lit up. Let's try to open it. Okay, and it is in process of opening the door, and we can see the relevant indicator is on and motor up is on. It has to stop when this relatively to this limit switch. Okay, it is completely open and the open indicator is on. Okay, let's try to close it, whether it will stop when it will be completely open. Yes, it works. Okay, now let's test our last constraint to stop it in between. Okay, so it does not make sense because it is already closed, so if we click on it, it is smart enough. Open it, stop it, open it, stop it. So we can stop in between wherever we want. Close, stop, open, stop, close, stop. So this is all about this assignment. I hope you would have enjoyed this, and you would have, even if it is very little, please don't forget to click on like button, which will encourage me to keep going to prepare such kind of tutorials. Otherwise,